Okay, let's talk about the data side of this project now. So there's this data directory located in our main project root that contains a bunch of different information about our config, different cultivations, our device, storing images, layouts, logs, etc. Probably the best way to do this is just to go through one by one and explain why they exist and what they're useful for. So looking at the config, this is the device.txt file that I've mentioned earlier, and this lists what device config I'm currently using. So I'm using the PFC3 v0.3.0 as reflected there. Also here, this has my RC local configurations, which you really don't have to worry about outside of installation, but an important note is that this RC local is symlinked to the one located in /etc/rc.local. So if you are trying to edit this file, it will change what's located in the /etc one. If we look into cultivations, this is, let's just open up the cultivars. Oh, that didn't work too well. Let's try that again. Rs, there we go. So this is a pursuit so that every single cultivar, cultivar is really just like a fancy name for plant. Every cultivar that enters into this system is well tracked. I think it's really important to be precise about the cultivars and what type they are of, so that as this project gets bigger and more devices come online and we all start forming this common language around how we talk about the data and how we talk about the variables and how we talk about what grew and how to replicate it, we're all speaking very precisely. So the cultivars is in pursuit of this idea. And it's a very early pursuit. So all this one is doing is saying, all right, we have some scarlet kale, giving some brief information, a link to buy the seed, and telling some properties about the height. So I imagine in the future there will be a bunch of different systems of different types. We already have a lot of different types in the OpenAg project. There's little cubic foot ones. There's also large shipping container scale or even tree scale food computers. So knowing how big the plant is going to get, I can imagine being pretty useful information in the future when you're choosing which seeds you want to cultivate. So that information is captured here. Also setting what seed stage it is. So is it a seedling? Are we starting from seed? Just really trying to be very precise about what state our cultivar is in. And really the same thing that's happening in cultivation methods. Right now we just have shallow water culture and soil. And again, I imagine this will expand out to be a lot more detailed. Not all soil is created equal. Probably not even the same on a day-to-day basis. So there's lots of interesting modeling problems to be solved in this area. So let's jump over to devices. And we can see all of our different device configurations. So we might as well open up our PFC3 0.3.0.json. And this is what specifies what peripherals we have, how we want to set them up, what variables they're speaking about, and whatever communication methods we need to interface with them. So the same paradigm is used for actuators, sensors, I2C sensors, USB sensors, etc. And then in this specific device, there's no controllers, but in some of the other devices where there are going to be temperature and humidity controllers, etc., this is the place where those will get defined. So the next one is images. Here, there's going to be images in here. Because I just installed all this software fresh, I don't have any images yet. But if you're looking at the local images, they will be located in this folder. as the images get sent to the cloud, they'll move from just the images folder into the stored folder. So if you're wondering where all your images are and you want to SSH into a machine and pull them off, this is where you go to do that. The next thing is layouts. This is another feature that really isn't critical to the device operation. Again, it's looking at building towards the future. And this came out by asking the question is, how can we get our data to be the most precise we possibly can get it? And from looking down that question, our team realized that, hey, a sensor that's at the top of a unit versus at the center of a unit or the bottom of a unit is going to be very different. And we've also seen the same point being made throughout the community, and we think it's a good one. So this is an exploration to look at what would it look like to speak that precisely about where different sensors are located, what different zones we have, and this really is a very early exploration, so it shouldn't be taken as this is what's happening. It's just a good starting point. So we have a bunch of these green racks in our shipping containers, and they have different physical parameters. They have a specific device zone, specific cultivation zones, and infrastructure zones, and also cultivar sites. So I really think that the cultivar sites, defining where those are laid out, are going to be quite important, especially as we're looking to do more and more with the cameras to identify specific traits about individual cultivars. We need to know where they are, and the camera needs to know how to, or where to look at them to associate whatever data it can infer about it and associate with the larger scale grow data that's going to be hosted up in the cloud. But that is a little bit zoomed out than what we're trying to do right now, so let's keep going. There's logs, which are exactly what you expect them to be. They're the system logs, so if you log into a production device and want to see what happened, make sure you go there. Then there's the recipes. These are all the recipes that are shipped natively on the device, so you don't have to send it from a cloud UI. Imagine a future where all these recipes are hosted in one single spot. There's already a bit of work being done on this in the cloud system, but it's not really synced between the device software and the cloud yet. So I imagine in the future they will be synced, and it'll be able to support offline operation as well as uploading new recipes from a device. So this is really just like the first pass at where all these recipes live on the device software. So if we open one up, I like if looks could kale. And this is just the general case recipe. Recipes really can come in a bunch of different formats. So this first one was built just to be pretty flexible, where you can specify the different format of the recipe. So if it changes in the future, no problem. We just have to learn that we have to process it in a different way, talk about the different authors, the description, what's being cultivated, how it's being cultivated, and then defining all of the environments. So I really like this paradigm of a dictionary or JSON notation where there's really just key value stores. So I applied the same idea to recipes, where we have environments that are just environment keys, so they're standard day, and that describes what that environment is going to be. And then there's phases. So within each phase, there are cycles, and the cycles are linked to a specific environment. So the standard growth cycle consists of a day and a night, and the environment in day is standard day, and the environment in night is standard night. But when we get into something like a frosty growth, because we're growing kale, and we read in the description that it makes the kale gets really crispy right after a freeze, we want to replicate that environment, so we're going to make a frosty growth, and the final day we're going to make really, really cold so we can make our kale nice and crispy. And we specify that our environment is going to be a cold day and a frost night. And then we will have our kale cultivated to be nice and crispy, just how we like it. So moving out of recipes, there's a lot more that we can talk about for recipes. and different editors and ways to create them, but really this is just like the baseline language, or a format of the baseline language. I don't think we know exactly how they're going to play out, but I think this is a pretty good starting point to evolve from for the recipes. And then we jump to registration, and this is all of the registration data that's generated by connecting to the IoT cloud, or Google IoT cloud. It has our private keys, verification codes, device IDs, etc. This you don't have to be too concerned about unless you're doing work on the IoT manager. The next thing we have are schemas. This is how we validate all of our JSON files. So let's jump into recipe. We require certain parameters to exist, like authors, names, emails, UUIDs, but also some are optional. And really what this is saying is if the JSON document is not structured as the schema says it should be, it will throw an error, and it won't be able to accept it when you create a new recipe or upload a new recipe. And finally, we have variables. Again, this is all in pursuit of having very clear and very well-defined data that's generated from these devices. Since we are working at multiple different scales of device and multiple different locations, we really have to be precise about the variables we're using so we're all speaking a common language. I really think that's critical, and can't hammer it enough. So if we open up these sensor variables, these are the sensor variables that I've come up with so far, or have ran into that I need to have added into the system. I know there's a lot more, and this is going to be a large collaboration amongst the open agriculture community. So again, just a first pass on what this could look like and how this could integrate into the OpenAg device software. But each of these variables are unique, and you can only use variables defined in the sensor variables file. So again, this will move and have to be synced up with the cloud to have a single source for all these sensor variables. But for now, they're all as far as the device is concerned, they're all located in the specific sensor variables file. So a good example of why we might care about this is, imagine I create a recipe, and in my recipe I say air temperature Celsius, and I use that as my key, and I say I want my air temperature Celsius to be 25. But maybe someone else, they don't like using air temperature Celsius. They want to use air temperature Fahrenheit, and they write their recipe to use air temperature Fahrenheit. If my system doesn't understand the difference between Celsius and Fahrenheit, we're going to have two very different temperatures in the box, and we're not going to have the same results. So also this prevents having these really annoying duplicate names where someone wants to use air temp, the other person wants to use air temperature, and it just creates this big messy data problem. So having these single source of truth for sensor and actuator variables, I think, is very important to the project. As the project progresses, I imagine there will be more and more data that becomes relevant to look at. But for now, this is all that I have to say on this topic, and I will continue on for the next videos.